Hi everyone, and welcome to our second short video in the series, Getting the Timing Right in Brine. Today we're going to have a look at the importance of the timing or scheduling for the propagation of synaptic activity. As you can imagine, timing plays a very important role. Here you only have to think of things like spike timing dependent plasticity. So I want to have a closer look at how scheduling plays into all this. So I've prepared a little example. Let's assume we want to evoke a spike at a specific time in a target neuron. So our target neuron is this one, the simplest neuron model you could imagine. You can think of this as a very simple leaky integrated fire model. And assume we want to evoke a spike at 10 milliseconds. So we create a spike generator group that spikes at 10 milliseconds and connect it via synapses to this group. And we make sure that the effect of this spike is very strong, so it will cross the threshold of the neuron and make it spike. Let's regard the spiking activity of the spike generator group and of the group that we want to make spike, run it, and do a little plot of the activity. The spike generator group spikes at 10 milliseconds as expected, but maybe surprisingly, the neuron group only spikes at 10.1 milliseconds, so one time step later. Why is this? We can have a look at the schedule of our network, which in our case is a so-called magic network, and we see the slots, the operations that happen at every time step, and we see that thresholds is the time point where spikes actually happen. And so what happens is that the spike generator group will spike in this threshold slot, then it will propagate the activity in the synapses slot, so it will raise the membrane potential in the target neuron. But that's basically then the end of the time step. So the receiving neuron will only check the membrane potential against the threshold in the following time step, and so it spikes with this one time step difference. So we could think of maybe we should change this schedule, and changing this schedule is pretty straightforward. We just assign to this argument that we just checked, and let us exchange the order of the thresholds and the synapses slot. If we do this and run the simulation again, we see that exactly nothing changed. And if we look a bit closer, then all this makes sense. In the threshold slot, the spike generator group will spike. This is at 10 milliseconds, but that's the end of the time steps. So in the following time step, we'll propagate the activity in the synapses time slot, and then the neuron group will check against the threshold and spike, but one time step later. So let's use our trusted scheduling summary function again and look at things in a bit more detail. So maybe before we look at this in more detail, one thing that can be annoying, especially for complex networks, is that these names are like neuron group 1 or spike generator group 1 are names that are automatically given by Brine if we don't name our objects. If we have a complex network, for debugging purposes like this, it can be very useful to name our objects. And so we can do this by giving them a name here when they are constructed, and one good way of naming them is simply using the same name that we use for the variables. So I'm going to name all the objects, including the monitors. In this case, we also have two monitors, so it's hard to tell the difference between the two. So we do this by giving a name everywhere. Oop. There we go. And if I now run it again and run, most importantly, the scheduling summary function again, we see that this now looks much more readable. So as we see, the spike generator group happens now because we changed the default schedule after the synaptic event, and the group threshold as well. So if we just change the global schedule for the network, then both of them change at the same time. So the trick, if we actually want to make our target neuron spike at 10 milliseconds, is to change these two things separately, the threshold checking of the neuron group and the spike evocation of the spike generator group. So we can do this with a when argument in the spike generator group, and in general with a when argument we can change the time slots of objects everywhere in Brine. So for example, a simple thing here to do would be to say that it should happen before synapses, which, as I explained in the last video, is a special slot that is automatically introduced and is, as the name suggests, before the synapses slot. So if we run this now again, we see that both the spike generator group and the target neuron group spike at 10 milliseconds. And of course, all this is reflected in the scheduling summary, where we now see that first the spike generator group here is active, and only later the synaptic pathway propagates the activity, and finally the group will check it against its own threshold. That's it for today. Thank you and bye.